Hi, I'm Kai, and now I'm going to do the question 1 of homework 6 for probability and stochastic processes. So the question 1, x and y have joint density function 1 plus xy divided by 8. We need to, the first question, we need to find 8 so that the above defined is a very joint density function. We know if fxy is a very joint density function, then the double integral of fxy dx dy will be equal to 1. And the region D is the absolute value of x is less than 1, the absolute value of y is less than 1. So for the x, the lower bound will be -1, the upper bound will be 1. For y, the lower bound will be -1, the upper bound will be 1. So it will be 1 times xy divided by 8 divide, and we calculate this integral first, and it will be y minus 1/2 times x times y squared, and y is from -1 to 1. So this term will be 2, and then we can calculate this integral. This integral will be 2 times x. X is from -1 to 1, so it will be 4. So 1/8 times 4 is equal to 1, so a is equal to 4. The second question, we need to find x and y uncorrelated. We know if x and y are uncorrelated, then e of xy will be equal to ex times ey. So we can find out the e of xy first. We know e of xy is equal to the double integral of x times y times the joint density function of xy. So it's the same for x, the lower bound is -1 to 1. For y, the lower bound is -1, the upper bound is 1. The joint density function is 1 plus x times y divided by 4. And so we calculate this integral first. It will be 1/2 times x times y squared plus 1/3 times x squared y cubed, and y is from -1 to 1. So it will be 2 divided by 3 times x squared. And then we calculate this integral. It will be 2 divided by 9 times x cubed, and x is from -1 to 1. So it will be 4 divided by 9. So 1 divided by 4 times 4 divided by 9. So e of xy is equal to 1 divided by 9. And then now we know the e of xy, and then we need to calculate e of x and e of y. And we know e of x is the integral of x times the density function of x dx. So we need to find the density function of x. We know by definition fx is equal to the integral of the joint density function of xy dy. So y is from -1 to 1, and the joint density function is 1 plus x times y divided by 4. So this term, we can rewrite it as the 1 over 4 dy plus x times y divided by 4 dy. So the first term will be 1 divided by 4 times y. Y is from -1 to 1, and it will be 1/2. And the second term is 1 divided by 8 times x times y squared, and y is from -1 to 1, and it will be 0. So the final result will be 1/2. And now we know the density function of x, and then we can calculate e of x. So e of x is the integral. X is from -1 to 1, x times 1/2 dx. So it will be x squared. X is from -1 to 1, and it will be 0. And for e of y is the same. We need to find out the density function of y. So the density function of y is the integral. X is from -1 to 1, and 1 plus x times y divided by 4 dx. So also we rewrite it as two terms. The first term is 1/2, and the second term is 0. So the final result will be 1/2. So for the e of y, will be the integral. Y is from -1 to 1, y times 1/2 dy. So it is also 0. So we know that e of xy is 1/9, and ex times ey is equal to 0 times 0 is 0. So e of xy is not equal to ex times ey. So x and y are not uncorrelated. The next question, are x and y independent? We note from the theorem that if we have x and y are independent, and then x and y are uncorrelated. Now we know x and y are not uncorrelated, so we can know x and y are not independent. So the question 4, find the joint density function of x squared and y squared. We can let z is equal to x squared and w is equal to y squared, and then we can use the fundamental theorem. If we want to use the fundamental theorem, at first we need to know all the roots of the equations. So for z, we know the absolute value of x is less than 1. So z is between 0 and 1. So for x, we can have two values, positive square root of z and negative square root of z. So for w, we know the absolute value of y is less than 1. So w is also between 0 and 1. For y, we also have two values, the positive square root of w and the negative square root of w. So we have four roots of these equations, square root of z and the square root of w, and minus square root of z, square root of w, square root of z minus square root of w, and the minus square root of z and minus square root of w. And now we have all the roots, and then we need to calculate the Jacobian. The Jacobian of xy is the derivative of z with respect to dx. So it is 2 times x. The derivative of z with respect to y is 0, and the derivative of w with respect to x is 0. The derivative of w with respect to y is 2y. So the Jacobian will be 2 times x times 2 times y, and minus 0 times 0, and it will be 4 times x times y. Now we have the roots and the Jacobian, then we can calculate the density function, the joint density function of z and w. So for the first root, fxy of square root of z and the square root of w will be 1 plus square root of z square root of w divided by 4. For the second root, it will be 1 minus square root of z times square root of w divided by 4. For the third root, it will be 1 minus square root of z times square root of w divided by 4. And the last root, it will be 1 plus the square root of z times square root of w divided by 4. So we can put the 1 divided by 4 here, and for the Jacobian, it is the absolute value of 4xy. So it will be 4 times square root of z times square root of w. So we put it here. So for the terms inside, the final result will be 4. 4 times 1 over 4 will be 1. So the joint density function of z and w will be 1 over 4 times square root of z times square root of w. The last question, prove or disprove that x squared and y squared are independent. We know if we know z is x squared and y and w is y squared, and if z and y are independent, then their joint density function fzw will be equal to fz times fw. So we can calculate fz and fw. So for z, the density function of z will be the integral of the joint density function of zw dw. So so w is from 0 to 1. So it will be and the joint density function is 1 over 4 times the square root of z times the square root of w. So it will be 1 over 4 times the square root of z times 2 times w to the power of 1/2. W is from 0 to 1. So the final result is 1 over 2 times the square root of z. For the density function of w, it will be the integral of joint density function of zw dz. So it will be so z is from 0 to 1. The density function is 1 over 4 times square root of z times square root of w dz. It will be 1 over 4 times the square root of w times 2z to the power of 1/2. Z is from 0 to 1. So the final result is 1 over 2 times the square root of w. So fz times fw is 1 over 2 times the square root of z times 1 over 2 times square root of w. So it is equal to 1 over 4 times the square root of z times square root of w, and it's equal to the joint density function of zw. So z and w are independent, and x squared and y squared are independent.